So in the last video lecture, we started talking about the relationship between distance and velocity. So I gave you a distance graph and kind of showed you how to find velocity from that distance graph. Well, since we can get velocity from distance, we can definitely go the other way. So let's say I give you a velocity graph. So a velocity graph, okay? Let's say these two friends, Sam and Karen, went on a road trip. And their velocity graph is given to you. So over here is time, and it's the AM. And over here is their velocity. So in miles per hour. Okay. So let's say they traveled from 8 a.m. to 10 a.m. And from 8 to 8:40, they traveled at 40 miles per hour. So from 8 to 8:40, their velocity was 40 miles per hour. Then maybe they hit the freeway, so they increased their velocity and started traveling at 60 miles per hour. And they traveled that way for a bit until about 9 a.m. Oh, sorry, actually, maybe instead we'll have them. Let's have them travel up to 55 miles per hour. So here's they went up to 55 miles per hour and they traveled for 55 miles per hour till 9 a.m. Then they increased their speed to 60 miles per hour and they traveled that way till about 9:40. And then at 9:40, they get closer to their destination, so they decrease in speed. They're back on the streets again, and they go down to 25 miles per hour. And they drive at 25 miles per hour for another for a little bit of time, and then they stop. Okay? So here's Sam and Karen's road trip. And instead of telling you the distance they traveled, this tells you the story of how fast they traveled, the rate of miles per hour at which they traveled. So again, from 8 to about 8:40, they traveled for 40 miles per hour. Then they sped up to 55 miles per hour. Then they sped up a little bit more to 60 miles per hour. Then they slowed down to 25 miles per hour, and then eventually they stopped. Here's 0 miles per hour, right? They're not traveling at all. Okay? So using this velocity graph, can we then find the distance? So let's see, what is the distance Sam and Karen traveled? So we know, again, that distance is equal to rate times time. And this is a constant, or this is the equation that we use. How far you travel is equal to how quickly you travel and how long you travel for. So we know, okay, that from 8 to 8:40 a.m. they travel, so from 8 a.m. to 8:40 a.m. they travel at a rate of 40 miles per hour. And they travel that way for 40 minutes. Okay? Well, we can't multiply these two out because they're different time units. So we can convert 40 minutes. Let's convert it. 40 minutes is, of course, multiplied with 1 hour per 60 minutes, which is just equal to about 6 hours. Okay, so then we can convert this and turn it into 40 miles per hour times 6 hours and multiply that out. We have 160 mile over 6, okay, which is equal to 4, about 26.6 miles, approximately 26.6 miles. Okay, so from 8 a.m. to 8:40 a.m., we found that their distance is rate 40 times time. So their rate is 40. This right here is their rate times the time. And so we found the area of the rectangle right here underneath the velocity graph. So we found the area under the curve. So to find the total distance traveled, we had to find the area under the curve. And it just follows from the fact that distance is rate times time. We literally did rate times time, which is the area under the curve, because it's a rectangle, okay? And the area of a rectangle is base times height. You can do that for all the other time periods. So let's say from 8:40 to 9 a.m. Okay, so from 8:40 to 9 a.m., she traveled at 55 miles per hour. So her distance is equal to 55 miles per hour times 20 minutes, which is 1/3 of an hour. Okay, we can multiply this out and we would approximately get about 18 miles. Okay, and then we can find, so we found again the area under the curve there, 20 minutes times 55, and then that's the distance she traveled. And you can do that for the rest of this and find the total distance she traveled, or the two of them traveled, from 8 to 10:20. So I encourage you to try and find the total distance they traveled on your own using this area under the curve. Okay. Another question that could come up with Sam and Karen's problem is, what was their average speed? So as you can see, they traveled at different speeds from this time at this time interval. And they traveled at 40 miles per hour for 40 minutes. And then 55 miles per hour for another 40 minutes. No, it's 20. Oh no, that's 15, 30, 45. Oh, actually, they traveled 40 miles per hour for 45 minutes, sorry. And then 55 miles per hour for 30 minutes. And then 60 miles per hour for 15, 30, 45 for another 45 minutes. And then 25 miles per hour for 15, 30 minutes. and then of course they stop. So this is the total of velocities they had during this trip for this time period. So how to find the average velocity of this problem, or average speed, okay? So the way you find the average speed is to take all your speeds that you have. So you did 45 miles plus, 40 miles per hour plus 55 miles per hour plus 60 miles per hour plus 25 miles per hour and then divide that by the total time that you traveled. So that would be from 8 to 10:15. So they traveled for 2 hours and 15 minutes, which is 2.25 hours. Okay, and then you can just plug this in and figure out what the average speed is. Okay, so as you can see, we can take our velocity graph and get some information about our distance. Okay, and this applies in general. Okay, if your velocity graph were to look like this, okay, and I were to say to you, well, what's the total distance traveled? So here's your velocity, here's your time. To find the total distance traveled, again, you need to find the area under the curve. And sometimes you don't know how to find the area, so you'd have to break it up into shapes you do know. So you could find the area of this triangle, then the area of this rectangle, then the area of this triangle, and then the area of this rectangle. Now, as you can see, the area of this rectangle is going to be negative. But since it's distance, so we're looking at distance covered, you're going to use the positive area because it's a positive distance traveled. This negative portion right here is saying that your velocity is negative, meaning you're traveling in the opposite direction. So this negative is a direction, okay? It tells you a direction. When you have a negative, it means you turn around and went the other way, okay? So anyway, you can use a velocity graph to also get a distance graph or the total amount of distance traveled over time.